All right, this video is going to go over pages 12 through 14, so we're going to do a lot of wave equation practice in here. But just a reminder to go back and look at your stuff prior to this. So when we have our quiz on this, there is still a lot of information on things like labeling a wave, the parts of a wave, knowing the difference between a transverse wave and a longitudinal wave, what makes up an electromagnetic wave versus a mechanical wave. Do you know your conduction, radiation, convection, those kind of things? Okay, so make sure you go back and look at that because a bulk of this quiz is not going to be all equation stuff. So there's about 3 questions on that. So you still need to do the equation part, but you still also need to make sure, don't get too hung up on the equation part and then forget to go back and look at all the other stuff. So that's just kind of a heads up for you. So universal wave equation practice, we're going to start on page 1. Okay, well, sorry, question number 1. So we're going to go through and we're going to write out our symbols, units, and equations for wavelength, frequency, period, and velocity. So wavelength is going to be your upside down y, that's your lambda. Okay, frequency is going to be characterized by the letter F. Period or time is capital T. And velocity can be V or C. So C would be the speed of light for electromagnetic wave, which we'll talk about more. So wavelength, so key thing here is length. Okay, length, the unit for length is meters. Okay, frequency is going to be hertz. Okay, period is time, so that's going to be seconds. And your velocity is in meters per second. Now equations, there's multiple equations to solve for things. It just depends on honestly what you have. So if I was looking for wavelength, I could use V equals wavelength times frequency. I could use V equals wavelength over a period. Okay, either one, it just depends on what you have. Frequency, you could do F equals 1 over T. You could do V equals wavelength times frequency. Okay, period, you could do T equals 1 over F. You could do V equals wavelength over T. Okay, velocity, so if you want to look for velocity, you could do V equals wavelength times frequency or V equals wavelength over T. Honestly, there's just different ways. It just depends on what you have. Now, these V's can be interchanged with C's just fine. Okay, C is technically, it's still a velocity. It's just the speed of light. And since it never changes, we keep it as C. Okay, so number 2, what is the speed of an electromagnetic wave? So remember, electromagnetic waves were your red Martians invade Venus using X-ray guns. So you had radio, okay, you had microwaves, you had infrared, you had visible light, which is your colors, Roy G. Biv. Okay, then you had UV light, and then X-ray, and then gamma. Those are all electromagnetic waves, okay? Those will always travel at the speed of light. Okay, C equals 3.0 times 10 to the 8th meters per second. So I will give you this value right here. Okay, so you don't have to memorize that, but you do need to know your electromagnetic spectrum. So the way we usually remember it is red, red Martians invade Venus using X-ray guns. Okay, so that whatever way you need to, okay, that however you need to do that, that's fine. Number 3, how can you change the velocity of a mechanical wave? So remember, a mechanical wave is a wave that needs a physical medium. It needs something like air, water, a way like a chain, a rope. Okay, so it needs an actual physical material medium. And the only way you can change the velocity of a mechanical wave is by changing the medium. Okay, so one example would be like sound. Okay, if you want sound to go faster, okay, you got to change the medium. Sound is actually pretty slow in air, okay, because particles are very spaced out, okay, so they can't transfer energy very well, okay, but if you were to take the same sound and introduce it to water or solid, it's going to travel even faster, okay, so if you want to make it go faster, you got to change the actual material of the medium. Number 4, what is the relationship between wavelength and frequency? Those are inversely related. So that means if frequency goes up, wavelength has to go down. So just remember that. Number 5, a water wave is propagating at a rate of 10 meters per second. Propagating just means moving through water. A water wave is propagating at a rate of 10.9 meters per second. That's your velocity. It is a wavelength of 122.5 centimeters. So that is wavelength. That's your lambda. Now, I can't have centimeters. Now, you could do this 2 ways. Okay, if you're used to using that prefixes box, which I'll talk about here in just a second, you could totally do 122.5 times 10 to the negative 2. That's totally fine. Okay, all you did was just add the centi on that. Centi is 10 to the negative 2. Okay, or divide by 100. Okay, so divide by 100, and that would be 1.225 meters. Okay, whichever way you prefer. And you're looking for frequency. Okay, so which equation has all that? So we have V equals frequency times wavelength. So V is 10.9. Frequency, we don't know. And wavelength is 1.225. Divide both sides by 1.225. Okay, and we get a frequency of 8.9 hertz. Number 6, calculate the wavelength of 103.3 FM waves. So I think we already did this in the last video, okay? But remember, and normally in the problem was I would tell you, okay, we kind of left off units on here, which probably should have put them on there. But radio waves, their frequency is always in megahertz. And if you look on, which we'll do it here in just a second, megahertz is 10 to the 6th. Okay, so what I mean by that is I'm going to scroll down here. I put our formula sheet on here. Is if you see a problem where it's like, if I say megahertz, so in that case, we had 103.3 megahertz. Well, if you look right here, okay, that big M is right here. There's your mega. So if you want to fix that, if you want to turn that into hertz, all you got to do is add times 10 to the 6th and you're good. Okay, that'll put it back in normal hertz. Okay, so we'll come back and reference that a few times during this video. So I'm looking for wavelength. So there's your looking for lambda. Okay, we're dealing with a radio wave. So radio wave is an electromagnetic wave, which means it travels at the speed of light. So 3.0 times 10 to the 8th. And then 103.3 is a frequency. Okay, so that is your frequency. So it would be 103.3 times 10 to the 6th since it's a megahertz. So we're going to use the equation C equals frequency times wavelength. So 3.0 times 10 to the 8th equals your frequency, which is 103.3 times 10 to the 6th. Okay, times your wavelength, and you don't know that. So divide both sides by your frequency. Just be careful. Make sure you use in parentheses. Okay, put both of them in parentheses. That will help you get a more clean answer. You should get a wavelength of 2.9 meters. T, what is the period of a 60 hertz electromagnetic wave? So period is big T. That's the time it takes for one wave. Okay, I have a 60 hertz electromagnetic wave, so that is frequency. So all I want to know is T. So it is electromagnetic. Okay, so you could try to use the speed of light if you want to, or if you go back and look at your equations, remember T equals 1 over F. Okay, so all you got to do is 1 over 60, and that gives you 0.017 seconds. So that is how long it takes for one wave to complete. Okay, so moving on to the next page. What is the frequency of a yellow light? So frequency, we don't know. I'm going to start writing things over here. Frequency is our question mark. Okay, yellow light. Okay, so yellow light is, that should be pretty dead obvious. It's light, so it's going to move at the speed of light. So that means we're going to do a C equals 3.0 times 10 to the 8th. And it has a wavelength of 580 nanometers. So we have a wavelength equals 580. Now be careful with this, nanometers. Okay, so what we're going to do is we're going to go back to our formula sheet. Nano is right here. Okay, so nano is 10 to the negative 9. So what I'm going to do is I'm going to come back up here, and if I want to fix that 580, all I got to do is add 10 to the negative 9 on there, and you're good. Okay, so that puts it back in meters. So I'm going to use the equation C equals frequency times wavelength. So 3.0 times 10 to the 8th equals my frequency, I don't know, and my wavelength is 580 times 10 to the negative 9. So divide both sides by your wavelength. Make sure you use your parentheses, and you should get a value of 5.17 times 10 to the 14th hertz. Okay, if you're not seeing that 14th, okay, make sure you look all the way to the right of your answer on the calculator. If you see that little e means times 10, so it can be real easy to forget that e. So I'll see students that will put 5.17 hertz and they think they're done. Okay, so they did it right, but they didn't look all the way to the right and they forgot to see that little e that means times 10. Okay, so, and also it is okay to get big answers. Okay, so you're dealing with the frequency of light. Okay, so there can be a lot of waves in a short amount of time. Okay, so next one, use this information for the next two questions. Radio stations are usually identified by their frequencies. Okay, one radio station in the middle of FM band has a frequency of 99.0 megahertz as it travels from the radio transmitter to your car. Okay, so you have the radio transmitter right here, so we'll just say that's the tower. Okay, what it's doing is it's sending basically a signal to your car. I know this is a very basic drawing of a car. Okay, your car is going to pick up that frequency, and then your car is going to adjust that into a frequency that you can actually hear. Okay, so the sound coming out of your speakers has a frequency of 440 hertz. Okay, you cannot hear radio signals. Okay, otherwise you'd be listening to 106.1 Kiss FM right now. Okay, so your car actually has to transfer it into a frequency you can hear through the speakers. Okay, so now one thing we kind of left off on here is we're talking about sound, and we'll give you this in the problems, and we'll give you this. You don't have to memorize this. The velocity of sound is 340 meters per second. Okay, so if you're dealing with sound, we're going to use that velocity. If I'm dealing with like a radio signal, which is electromagnetic, I'm probably not going to use that velocity. I'd rather use the speed of light. So number 9, what is the wavelength of the radio? So you're looking for wavelength. There's your question mark. Of the radio wave. So we're dealing with a radio wave, which is electromagnetic, which means we're dealing with the speed of light, 3.0 times 10 to the 8th. Sent from your station's transmitter to your radio. So if we're going from the station to your car, okay, that has a frequency of 99.0 megahertz. Okay, so your frequency is 99.0. Now megahertz can't have that, so I'm going to go back down here. Megahertz, we already hit it, is 10 to the 6th. So what we're going to do is we're going to add 10 to the 6th on that 99. So there's your frequency. And we're going to use our equation, C equals frequency times wavelength. So 3.0 times 10 to the 8th equals my frequency, which is 99.0 times 10 to the 6th, times your wavelength, which we don't know. Okay, so you're going to get a wavelength of 3.03 meters. Now, number 10, it says, what is the wavelength? So we're looking for wavelength again, but now we're talking about the sound wave. Okay, sound wave that's going to your ears. So the velocity of sound is 340 meters per second. Okay, and now remember the frequency to your ears is 440 hertz. Okay, so coming out of the speakers is 440 hertz, which is a lot easier to hear than 99.0 megahertz. Okay, so your frequency is just 440 hertz. So you don't need to add the times 10 to the 6th here, so be real careful with that. There's a difference between megahertz and hertz. So we're going to use velocity equals frequency times wavelength. Okay, so velocity is going to be 340. Frequency is 440. And wavelength, we don't know. Divide both sides by 440, and you get a wavelength of 0.77 meters. Now, what is the frequency of a 1.5 centimeter long microwave? So frequency, we don't know. Okay, 1.5 centimeter long microwave. Okay, that is your wavelength. Okay, so 2 ways you could do this. You could do 1.5, and you could go all the way down here and look at centi, and centi is 10 to the negative 2. So you could do 1.5 times 10 to the negative 2 if you want to. That's totally fine. Okay, or divide it by 100, and you get 0.015 meters. Okay, so that would be your wavelength there. And we're dealing with microwave, so microwave is electromagnetic, so that means we're dealing with C equals 3.0 times 10 to the 8th. So we're going to plug in, so 3.0 times 10 to the 8th equals my frequency, I don't know, and wavelength is 0.015. Okay, so divide both sides by 0.015, and you get a frequency of 2 times 10 to the 10th hertz. Number 12, how long does it take for a radio signal to reach the other side of the globe? So how long does it take? That means we're looking for time. Okay, so you can characterize it by T or big T. In this case, it wouldn't be that different. Okay, so how long does it take? We're talking about radio signals, so we're going to deal with the speed of light, so 3.0 times 10 to the 8th. And how far does it have to go? So 20,000 kilometers. Okay, so that's a distance. Okay, so you could put that as a wavelength if you want to, or you could put it as distance. Okay, so remember, don't forget we have the equation V equals D over T. Okay, so still technically the same thing. It's still technically wavelength over time, so you wouldn't really be wrong if you labeled it different ways, but technically we're just doing velocity equals displacement over time. Now, be careful with this. You're in 20,000 kilometers. 1 kilometer equals 1,000 meters. Okay, so I do see a lot of confusion on when to divide and when to multiply here. Okay, if 1 kilometer equals 1,000 meters, okay, I'm not going to divide by 1,000 and make that smaller. Why would there be less meters in 20,000 kilometers? Kilometer is very big. So what you do is you'd multiply that by 1,000. So your distance is now, instead of 20,000, it's now 20 million meters. Okay, so we're just going to basically do V equals D over T. So 3.0 times 10 to the 8th is your velocity. Okay, distance is 20 million meters. And t we don't know. Okay, so that's what you're looking for. So remember, if there's a variable on bottom, just switch those two. Okay, so 20 million divided by 3.0 times 10 to the 8th. That means it only takes 0.067 seconds for a signal to get across the globe. Pretty nuts. Number 13, UV radiation. So UV radiation, dead giveaway. We're dealing with electromagnetics. So that's C equals 3.0 times 10 to the 8th. Has a wavelength of 300 nanometers. So wavelength, 300. Can't have nanometers, so you go back down to your box. We've already done nano. Okay, so that would be times 10 to the negative 9. Just add that on there. Find its frequency. So that's your question mark. So we're going to plug in 3.0 times 10 to the 8th equals frequency I don't know. And my wavelength is 300 times 10 to the negative 9. Divide both sides. Okay, you get a frequency of 1 times 10 to the 15th hertz. Number 14, what is the wavelength of a tone? So wavelength we don't know, that's what we're looking for. Of a tone is 256 hertz. So tone is technically a sound, but in this case, it doesn't matter, we could put anything there. Because as soon as I say hertz, I just told you that was frequency. So 256 hertz would be your frequency. And the speed of sound is 340 meters per second, so I went ahead and told you the velocity is 340 meters per second. So we're just going to use our equation, V equals frequency times wavelength. Okay, so velocity is 340. Okay, frequency is going to be 256. And wavelength we don't know. Okay, so divide both sides by 256, and you get a wavelength of 1.33 meters. Okay, moving on to the next one, 15. Sound waves travel about 5 times faster in water than air. Okay, so you can do this one of two ways. So if you're going to do the velocity is 5, if you want to go ahead and do it in water, you do 340 times 5. Okay, so since it's 5 times faster, we want to figure out how far does it travel in the same amount of time in water versus air. Okay, so if you do velocity times 5, so we'll do 340 times 5. Okay, that gives you 1,700 meters per second. So that's how fast it travels in water. Okay, and we want to know how far does it go, so displacement we don't know. And then we have 0.1 seconds, that's your time. So V equals D over T, so 1,700 equals D, which we don't know, so over 0.1, so multiply both sides by 0.1. And you get a displacement of 170 meters. And that'd be your answer. Now, I calculated how far it would go in the air as well. So if you did it in the air, it'd be 5 times less. So it would only go, what I got, 34.5 meters in air. Okay, so it's kind of crazy how far and fast it can travel in water versus air. Okay, so you don't need to answer, you don't need to give me this. Okay, I was just showing you the difference. Number 16, the frequency of red lights. Okay, so red lights. So we're dealing with electromagnetics. C equals 3.0 times 10 to the 8th. Okay, I gave you frequency. So frequency is 4.6 times 10 to the 14th hertz. What is the wavelength? So we didn't have to do anything like mega, any of that stuff. So we're just good there. We don't have to worry about using that box. So 3.0 times 10 to the 8th equals frequency 4.6 times 10 to the 14th. And then wavelength, we don't know. Okay, so divide both sides by your frequency. And you're going to get a wavelength of 6.52 times 10 to the negative 7 meters. 17, how long are sound waves with 50 hertz? So sound waves. So again, typically we would give you this, 340 meters per second. Okay, I gave you frequency right there. So frequency is 50 hertz. How long are they? So that means you're looking for wavelength. So we're going to do 340 equals frequency, which is 50, times wavelength. So divide both sides by 50, and you get a wavelength of 6.8 meters. How far do radio waves travel in 1 times 10 to the negative 4 seconds? So that means you're looking for displacement or distance. Dealing with radio waves, so speed of light, 3.0 times 10 to the 8th. And I gave you time, okay, so 1 times 10 to the negative 4 seconds. Okay, so you can do V equals D over T, okay, so that's fine. So My velocity would be 3.0 times 10 to the negative 8 equals displacement, I don't know. And my time would be 1 times 10 to the negative 4. So multiply both sides by your time, and you're going to get a displacement of 30,000 meters. 19, water waves hit the shore every 3.5 seconds. So there's your time, so 3.5 seconds. And are 12 centimeters apart, so that's your wavelength. So go ahead and divide by 100 or add times 10 to the negative 2. That's totally fine. Okay, so your wavelength. So I'll write them both. So if you want to do 0.12 meters, that's fine. Or if you want to do 12 times 10 to the negative 2, okay, you could do that. Fine, that's either way, works. Okay, what is their velocity and frequencies? That means you're looking for V and we're looking for F. Okay, so I already know T, so I'm going to go ahead and find F. That's the easiest one. So F equals 1 over T. Now, could you do this another way? Yeah. I mean, you could go backwards if you want to. Okay, doesn't matter to me. As long as we get the same answers, you're good. Okay, so 1 over 3.5, and that's going to give you a frequency of 0.29 hertz. Okay, so we have a frequency. That's done. Okay, so we're looking for velocity. So remember, velocity equals wavelength over T as well. Okay, so we'll give you that equation. So like down here, I give you your equations here. I give you V equals frequency times wavelength. I give you V equals wavelength divided by your period, your time. C equals frequency times wavelength. These two are basically the exact same thing. Okay, the only reason why it's C instead of V is because C is when you're dealing with electromagnetics, and it'll never change. Okay, when you're dealing with like things like sound and water and air and stuff like that, this velocity right here can change all the time. Okay, but when you're dealing with electromagnetics, this C doesn't change. Okay, it's still a velocity, but the reason why we have it as C is because it stays constant. Okay, so that's kind of like a little tip for you. So V equals wavelength over T. Okay, so velocity we don't know. Wavelength is going to be 0.12 divided by your time, which is 3.5, and you get a velocity of 0.034 meters per second. 20, calculate the wavelength of a 10 kilohertz sound wave. So you were looking for wavelength. Okay, 10 kilohertz. Okay, so that's your frequency. So if you go down to your chart right here, kilo is right here, 10 to the 3. Okay, so you're going to do is you're going to do 10 times 10 to the 3 hertz. So that fixes that. Okay, and remember you're dealing with sound, so velocity equals 340 meters per second. So 340 equals my wavelength times frequency. So wavelength I don't know. Frequency is 10 times 10 to the 3. Okay, divide both sides by that frequency, and you get a wavelength of 0.034 meters. What is the frequency of a 1 centimeter long sound wave? So frequency we don't know. Okay, we have 1 centimeter long sound wave. That's your wavelength. So divide by 100 or add times 10 to the negative 2. Doesn't matter to me. Okay, so that gives 0.01 meters. Okay, and you're doing sound. Sound is V equals 340 meters per second. So V equals frequency times wavelength. So 340 equals frequency, I don't know, and wavelength 0.01. Divide by 0.01, you get a frequency of 34,000 hertz. 22, last one. What is the frequency of a 1.5 centimeter long radar wave? So radar it's a type of light wave. Okay, so you're going to lose electromagnetics here. So C equals 3.0 times 10 to the 8th. You're looking for frequency. That's your question mark. And you have a wavelength of 1.5 centimeters. So divide that by 100. And you get a wavelength of 0.015 meters. So 3.0 times 10 to the 8th equals frequency, I don't know, and wavelength 0.015. Divide both sides by your wavelength, and you get a frequency of 2 times 10 to the 10th hertz. All right, and that will end that one.